Today's excerpt is brought to you by the fun fact, chaos theory. Chaos theory is the branch of mathematics that attempts to account for the fact that many systems are not successfully described by the linear equations used in traditional math and physics. The, quote, chaos in chaos theory doesn't mean messy or disorganized, it just means nonlinear, and hence virtually impossible to predict. A common example is the weather, where tiny changes in atmospheric conditions in the Pacific Ocean can produce enormous changes in a weather system by the time it reaches New England. Another common example is a pool table, where tiny variations in the air currents, bumps on the tabletop, and the force of a given shot make it impossible to predict where the ball will end up after 10 ricochets off the table rim. Such systems are called nonlinear. The equations that describe them contain a lot of exponents, and the graphs that map them contain curving lines instead of straight ones, hence their description as being nonlinear. This means that tiny changes in the initial conditions can lead to enormous variations in the final result, and seemingly simple systems can produce complex behavior. A simple mathematical demonstration of this is the fact that 2 to the 10th power is 1064, while 2.1 to the 10th power is equal to 3503. A small increase in the number taken to the 10th power yields a product more than 3 times greater. An early pioneer of chaos theory was meteorologist Edward Lorenz. In 1961, using an early version of a computer to run his weather simulations, he found that very small changes in the initial assumptions produced big differences in the weather predicted at the end of the run. His discovery was actually an accident. He repeated a computer simulation by entering values from a printout rounded to 3 decimal places. The original simulation had used values carried to 6 decimal places. To his surprise, the second simulation gave a completely different outcome. It turned out that simply rounding the numbers to more or fewer decimal places made a big difference in the end result. In 1972, he gave a paper at a meeting of the American Association for the Advancement of Science entitled, "Predictability: Does the flap of a butterfly's wings in Brazil set off a tornado in Texas?" thus coining the term the butterfly effect, commonly associated with chaos theory. Many important systems are now thought to be nonlinear. For example, the evolution of life on Earth may be such a system. A tiny change in, say, the percentage of oxygen in the atmosphere a billion years ago might have resulted in an unrecognizably different collection of living creatures today.